Good morning and welcome to the channel. Today we are doing an electrical installation conditioning report in Plymouth, and we're also going to be installing a kitchen light supplied by our customer. So what I will do is take you for a little walk through, and then during this video I will put pictures in there showing what I'm finding and my test results. If anybody's got any comments on this install, please leave comments in below. Don't forget to press the like button and subscribe, and always hit the bell icon. So here we go. So we have a fuse box brand. Now, is this board going to be neat or not neat? Shall we have a look? I would say that is not very neat at all. You can't clearly see where each cable goes, and it hasn't really been installed in a very nice fashion. You will note that on circuit 2, which is this circuit here, there is 3 cables going into the fuse up there above. Now apparently, according to my customer, this board hasn't been fitted for very long. However, there's 2 spare ways. Now I know you can see one module here, but they put a normal blank plate in the second module. So for whatever reason, they haven't put that circuit on its own fuse. So for instance, there's a ring main and a radial in that circuit, in that fuse there. And really, ideally, the radial shouldn't be in there with the ring main, because currently that radial is getting 32 amp supply and it can only handle 20 at maximum. If you'd like me to do a video and to explain to you according to BS 7671 of the wiring regs and show you in the book how to calculate circuits, then please leave that in the comment section below and I'll be happy to do so. There are bonding and there is main earth there installed, so that part of it will be okay with. Then the meter tails have quite a bit of copper on show. I'm not very happy about that. I will measure it. In fact, to be honest, I'll probably re-terminate it because of my OCD. So let's take you for a little walk around, shall we? So this is the bedroom, and they're quite high ceilings. There's a normal standard light pendant there. Lovely Victorian windows here. I believe this was once owned by the military before it was converted into flats. So the admirals would have had lovely views, etc. This is the hallway. Standard light fitting. There's a smoke alarm. Now, you will need to know that that smoke alarm should be 300mm away from this light fitting. I have measured it. It is. So on this occasion, that will do. But also because there's numerous flats here, there is an actual building fire alarm system. So this is a smoke alarm system. That is a fire alarm system. The difference being is that this one's wired throughout the whole property and has a fire control unit. This will notify every flat in here that there's a fire. This one will only notify this flat that there's a fire. So, normally, there is a fault with the fact that people don't install bathroom lights, but on this occasion, that is a bathroom light. So what that means is that it's IP rated, ingress protection, and it is IP 45 or above. So this one here, I believe, if it is the Mega Man, which I will double check, that is IP 65. I will double check that in a moment. There is a shaver socket there installed, which is fine and meets the regulations. And this is part of your SELV and PELV, so you need to note this on your certificate when writing those up. And they've got a pull cord light switch, which is fine to be within inside the bathroom. If it was a rocker switch on the wall, that wouldn't be acceptable. You should always be installing those on the outside. Basically because, you know, Tom comes out of the shower, he touches the light switch with wet hands, he gets electric shock. The thought process behind it is that Tom gets out of the shower, dries himself off, comes out of the bathroom, and then turns the light switch off with dry hands, not wet hands, and not getting electrical shock. this lovely size lounge. Once again, tall ceilings, which I do rather like myself. And the electrics within here look good. I mean, they're running trunking and surface mounted in areas. And then there are some that are embedded within the wall. This is a USB socket, so we need to remember that we need to disconnect this socket and connect the cables together under installation resistance testing. I will now take you into the kitchen. Now this is the light that I've got to change in a moment. The new light is down there. I will be taking pictures during the installation to show you this. This one here is the old type bulbs, which is a G9 bulb, push pull bulb. That's an old school fitting now, really, and they're not really nice bulbs to fit. Some people would call bulbs lamps. I think that's a bit pedantic. You know, commonly Tom, who's not an electrician, wouldn't know the difference between a bulb and a lamp. But in college they will say to you that bulbs grow out of the ground and lamps go in fittings. So there's some under cabinet lights here. Not the best ones in the world, but they are okay. They're in enclosures, so the terminations are fine, and I'm quite happy with that. The switches are far enough away from the cooker, and the ones above the sink have already been capped off and blanked off. The fuse spare has been installed above the boiler, so it's high enough, and it's well without the zone. It's well out of the zone of the sink. So I will now start to do some testing here, and I'll take you along for the journey. Stay tuned. And today our testing will be conducted by the Mega 1741 Plus, so that's MFT 1741 Plus. The difference between the 1741 and the 1741 Plus is that this tester can do EV charging points. That's electrical vehicle charging points, which us, Goodwin Electrical, install commonly quite often. And you will note that my tester is calibrated. It was done on the 12th of February this year and is still got until the 12th of February next year. So that is fine. I will take you to the testing. We're now ready to start doing ZE testing, which is the first test that you do from the main incoming supply. I will show you me putting my tester on, performing the test, and recording them on my documentation. So for this we need to set the Mega to LPE and not Z max, because this reading will not be conclusive if we do that. Let's put this to Z, and then what we need to do is we need to change this by using the arrow buttons from 3 lead low to 2 lead high. This now says 2 lead high. We're ready to conduct our tests. Okay, for the ZE test, as you may or may not know, but I will explain it to you anyway, to have a conclusive test, to remove all parallel paths, we need to remove the main earth conductor. So we'll be putting the earth clamp onto there from my Mega, and then we need to put the live onto the live terminal. This will give us a reading. That is 0.24. So this supply is a TNCS supply. The maximum reading for a TNCS is 0.35. If it was a TNS system, it would be 0.80. And if it was TT, it would be 200. I've put this here to remove customers' details. So we need to put into the ZE that figure with 0.24. 0.24. Right, and that is that. We can't record this figure just yet, the PFC, because the main earth is disconnected. And for us to do a prospective fault current test, we need to test between live and earth with all parallel paths connected. Then we need to do a PSFC, which is a prospective short circuit fault current test between live and neutral. Both these readings will be displayed up the top here, and we need to record our highest figure, and that it will be our PFC. Now the main earth is now reconnected, we will now perform PFC. We need to put the live onto the live terminal, our earth is on the earth terminal, and it's 1.18. We will now test between live and neutral. Testing between live and neutral. .18 was our highest, and that is what we will record. Okay, so now we're going to do some end-to-end testing on the ring final circuit. So what we need to do is pick up our tester and set this to the ohm setting, which is just there. But we need to know our leads. So to do that, what we need to do is grab our two clamps, and notice you've got the flat side of the clamp here and the flat side of the clamp there. We want the two flat bits to go together. Once they're together, make sure that they're snug, and your tester will come up with this. And if you notice on the Mega it's flashing, well, if you don't press the test button here where my finger is, once to cancel the null and again to add the null back, it will keep flashing and it won't give you a reading. It happened to me on a job not that long ago. So now we're nulled, I'll show you the socket. So what I'm going to do is put the first clamp on. I'm going to do the RN, which is the neutral conductor first. So one clamp's on that side, that's leg 1. This is leg 2. We're going to put the other clamp here. And we've got a reading of 0.60. Now remember that figure because it's going to be quite important in a second. Then we need to do the R1, which is the line conductor or live conductor, depending on how you're calling it. It's a dead match, which it should be because it's the same size conductor, 2.5 millimeter, 0.60 ohms. Now, if we take 0.60 ohms, our earth conductor should be 1.67 times that figure. So we get 0.60, we times it by 1.67, and that will equal 1.00. So now we need to measure our CPC conductor, which is the earth conductor. So leg 1, and that's leg 2. And we got better 0.99, which is basically bang on 1.67. That is saying that our end-to-ends are acceptable in accordance with BS 7671 of the wiring regs. Stay tuned, I'll take you to the next test. Okay, so we've put the front cover of the fuse board back on, and we are now going to re-energise all the circuits. We'll start with the main switch, and then we'll get the SPD to go up, and then all the socket circuits, the cooker and the light. I have done all of them before the functional tests, so stay tuned and we'll get some live tests in. So we'll start off by doing a ZS and an RCD test on the cooker circuit. I'll flip you around and show you how I'm doing that. So we're going to put our tester into the cooker circuit plug first, leaving this off. Coming to my tester and turning this to LPE. Keeping it on Z for this test. Ensuring it's on 3 lead low. And ensuring that it's doing AC and not DC testing. We'll energise and we will get the reading. .28. We need to turn this to do RCD testing. We're going to just do the 1 times because that's what NIC would like. So we'll do it at 0 times. So that's 1 times, that's 0. I'll just go and reset the RCD, well, it's the RCBO on this one. I'm gonna do it again. So we'll turn this now to the other side of the waveform. It's 180 degrees at one times. So we got 38.6. Okay, we need to do the socket circuit in the kitchen. So we need to turn our tester to LPE, but this time we're going to put this dial to max, Z max, and it will remember my highest reading. So we're going to plug it into a few sockets in the kitchen. .27. We'll check the other socket up. There's only two here. So we'll be recording 0.30. And some RCD testing. We'll just do the 0 times I'm recording this time, as I've shown you how to do both sides over there. This will be the final RCBO testing that I will do on this video, but I will obviously conduct the rest. 29.0. Okay, now we've done the testing, we're going to now change this light fitting. I will spin you around, put some music to it. Watch me change this light. Pause you halfway through, but the reason I stuck a screwdriver up was just to ensure that there's a joist there, and there is, so that's why I've not roll plugged it. I wanted to point that out to everyone on this video. Back to the installation. Okay, so I brought you down here to explain that this fitting, yes, it is metal, but it doesn't require an earth. You got this box and a box symbol, which means it's double insulated, and it's also one on the actual metalwork as well. So there's no direct contact with the electric and the metal, so therefore it's a class 2 fitting. It does not require an earth. And this light specifically has got these sticky grey things over the LED bulb. And there's your bulbs. Yeah, lamps to some people. So we're going to screw the lamp covers in now. Now go and energise it. Okay, the moment of truth. It's quite a nice fitting, that, isn't it? Nice illumination. Right, well, thank you very much for viewing that. That was an electrical installation condition report for a 1-bedroom apartment for a customer in Plymouth, and it went rather well. You also have just witnessed me changing a light fitting in the kitchen for that customer. All aspects of this job went very well, and couldn't have asked for better. So for all your electrical needs, contact Goodwin Electrical today for a free quotation. And don't forget to hit the like button, subscribe, bell icon, and comment down below. Just as a disclaimer, everything I've done today, please do not try and conduct any of what I've done today unless you are a fully qualified electrician and registered to work. It is extremely dangerous, and you shouldn't be trying to conduct this if you're not qualified to do so. Thank you once again for watching this video. Bye for now.